In this second part, dedicated to the Nodered, we will see how to communicate with the XM and send and receive data from the Nodered. In this example, we will see how to inject data, how to visualize them and their formats. We will see how to read data in Nodered from XM, and how to send data from the network node to the XM, and of course the example of the XM program used. Data injection example, visualization and formatting. Before starting with communications, let's see how data management works, at least partially, and so that you understand how the system works. This data will be received in buffer format, which means that they will arrive all grouped, and that therefore they must be manipulated to separate them. To start, we will use the inject function and place it in the flow editor. In the function, we will modify the name more than anything to know what we are doing, keeping the message payload option and then choosing the buffer type in which we will introduce 7 elements that will form the buffer as can be seen in the image. Remember that to validate the modifications we must do it with deploy. To make the example relatively simpler, the first thing will be to place a debug function and observe the result show after injecting the values. As you can see, the bug tells us that a buffer of 7 elements has been generated and that these appear one after the others and therefore grouped. This in general and according to which cases we will already do well, but most of the time the data received or sent must be treated individually. In the following image, we can see how the injector now sends the data to the extraction function of the 7 elements, and that each of them has its text, which allows us to see in the dashboard, and its debug, which what we can see directly. In the results, we can already see that this comes separately and that therefore something as managed that they do not come all grouped. In the image you can see how after the injector each of the buffer's elements defined as offset from 0 to 6 have a function before connecting with the text or the debug. This function performs the separation of the data coming from the buffer sent by the injector. In the function of each of them, the following is executed: reading the buffer with message payload that is sent to the read buffer variable. Then the value of the offset read in the image 0 is deposited to the variable value, and this value is copied on the value that we will return and at the exit of the block, and that we will show in the dashboard and in the debug. Here you can see the code used in the function and how the buffer of each of the elements is cleared. The instruction is the same and only the offset number used changes. It is very important to keep in mind that data of this type are always manipulated in byte format, and although in this example this does not have any importance, if it must be taken into account if the data are part of a structure in Word format or even in real format, since obviously is they will be affected, as we will see later in the examples for sending and receiving data from the XM. The following functions are used to display the values extracted earlier in the debug. And obviously the following functions send the values to the dashboard. Reading data in the node network of ctrlX core. The first step to establish communication with the XM is to assign the IP and the port that we are going to use. As output of the modules, we must choose the stream of buffer format that, as we can see, show as the value received from the XM. The structure sent is if we observe the debug module indicated that we are receiving a buffer of 20 elements. This means 20 bytes, although the actual structure used is 10 words. Therefore, what we are seeing is all the bytes corresponding to the 10 words. In the image, the control of data sent from the XM has been disabled to be able to visualize the value in a fixed way. In this way, we can visualize everything more clearly. As you can see, the arrival of the corresponding bytes comes with the rotated order and must be treated later. In the following image, we can see the shipping structure from the XM. As you can see, the data arrived at the debug in buffer format on 20 elements and grouped into blocks of 10 elements. If we access them, we can see the values of each one in hexadecimal, although the data as I have already mentioned arrive in the correct order. By not being able to use the data directly, we must use a new function to separate the elements of the buffer. For the extraction of the value arrived from the first word of XM, we will do it as follows. In this case, we are interested in extracting a 16-bit register in Word format. As we can see, we can do it in two ways, although only one of them allows you to choose the selected offset in the correct order. On the left, and using the read uint 16LE instruction from offset 0, the values are grouped correctly and the value from the XM appears as it has been sent. Wherever on the right, and using read uint 16PE and with the same offset, the value does not correspond to what was sent. Therefore, we must use the option on the left. Here we can see a list of the different conversion methods, including those used in the previous example. Obviously, if we want to receive all the data, we must include the structure for each of the offset, taking into account that this will be assigned 2 by 2. In the output modules, we can modify the number of outputs if this is necessary. Sending data from the Nodered to the XM. To send data to the XM, we will use an injector as we had done before, and then we generate the buffer elements taking into account that the data will be sent with the order of byte changed, so they must be treated. For the conversion of values and structuring the order of the bytes, we will use a function that works in two parts. The first part reads the buffer structure and replaces the bytes with the read uint 16LE instruction according to the offset. Then these already adjusted values are writing on the output message payload and is prepared to be sent correctly. Example of X structures sent from the injector and how they reach the XM. Offset 0, offset 2. As you can see, the values are generated inverted from the injector and are placed correctly by the function, appearing the values correctly the XM. The next two blocks allows us to send the data and visualize them in the debug. The instruction in the TCP out node is simply reply to TCP. For the sending instruction, it is not necessary to indicate neither the port or the IP since the system keeps open the connection that we have previously opened. XM program. The example of the XM program is practically the same as that used in the previous manual of the cyclical communication, although in this case the mode type has been changed to cyclic event server. The first segment is the blink for communication restoration control. The second segment manages the enable bit to activate the communication module. In the third segment, the operation mode is selected. In the fourth segment, the communications module is activated. In this case, the same blink of segment 1 must be used for the activation of the send signals since in this mode, cyclic event server, it is necessary to manage this entry. In the last segment, a value is sent in counter mode to the Nodered. This mode, and used in conjunction with the network mode, allows the reconnection of the communication in case of error in the same. Example of value sent from the XM to the Nodered and displayed it in the dashboard. Thank you for your attention.